All right, we're going to look at solving systems of linear equations by substitution. And this technique can be used for more complicated systems besides just linear, but usually you start off with linear equations. So we're talking about a system of linear equations when you have more than one equation and you're trying to find out where these equations all coincide at what x and y pair, where do they intersect. Now, one way to solve these systems is by graphing, but the problem with graphing is if they don't cross at a nice spot or they cross at really large numbers or something, it may not be the best way to do it. You can only be as precise as your graph is drawn. So what we're going to look at is some other technique. Another technique is the substitution method, and then there's another way to do it, which is sometimes called the addition or elimination method. So first thing we want to do is to use substitution is solve an equation for a variable. Now what I mean by that is I don't mean to plug numbers in and see what you get. We're not finding intercepts. What I want to do is I want to get a letter by itself. So I'm going to choose either to get the first x by itself, the first y by itself, the second x by itself, or the second y by itself. And if you had more complicated equations than linear equations, then you would want to pick the simplest equation. So what I'm going to do is, to make my life as easy as possible, I notice this first x has a coefficient of 1. So I'm going to get that by itself. So I'm going to take that first equation, and I'm going to get x by itself, so I'm going to add 2y to both sides of the equation. And again, the 4 and the 2y don't combine because they're not like terms. So that's the first step. You get one equation solved for one variable. X equals 2y plus 4. X is the same as 2y plus 4. The second step is to substitute the expression in place of the variable in the other equation. Be very careful. You realize where we got this x equals 2y plus 4. We got it from the first equation. So what I want to do is I want to take the second equation and I'm going to replace x, the letter I got by itself, with this 2y plus 4. So this second equation is now going to say 3 times stuff plus 4y equals 2. And then I'm going to fill in this stuff, 2y plus 4. I'm replacing x with 2y with the expression 2y plus 4. Now, a good kind of indicator that you probably did it correctly is at this point you should only be dealing with one type of letter. And you notice I only have y's in my equation, no x's. So that probably means I did it correctly. If I still had x's and y's, I did something wrong in my substitution. All right, so step 3, solve. So now I'm going to solve this equation. So I'm going to distribute that 3 times 2y and 3 times 4. So plus 12 plus 4y equals 2. Let's get our 12 to the other side of our equation. 6 plus 4 is 10y equals 2 minus 12 is negative 10. Divide both sides by 10. And you get y equals negative 1. Now, if you remember when we solved systems by graphing, we're looking for its point of intersection. This is half our solution. We have, our answer is something comma negative 1. What we need to do is find that other thing. So then step 4, back substitute to find the other coordinate. And again, if you're dealing with complicated type of equations, you'd always go to the simpler equation to plug this y equals negative 1 in. But since these both are linear equations, you can plug it in for y in this equation, plug it in for y in this equation. Or notice we've already solved this first equation for x. We could stick the y in there. So 2 times negative 1 plus 4, that will tell us what x is. So negative 2 plus 4, so x must be positive 2. So our solution is 2, negative 1. Let's do another one of these with a slightly more complicated system. Let's go with something like negative 2x plus 7y equals 9, and 3x plus 2y equals negative 1. So I have this system. Now, like I said, if I had one of these variables had a coefficient of 1, that's probably the one I would try to get by itself. In this case, nobody has a coefficient of 1. We got negative 2, we got 7, we got 3, and we got 2. Just got to decide who you want to stick with. Just for the sake of being different from what we just did, I'm going to use the second equation, and I'm going to solve for y. So I'm going to take this second equation here. I'm going to get y by itself. So, excuse me. I'm going to get rid of this 3x here by subtracting it. 2y equals negative 3x minus 1. Divide by 2. And I get y equals negative 3/2 x minus 1/2. And again, I have fraction. You could work with decimals, negative 1.5x minus 0.5 if you wanted to. But there was no nice, clean variable to solve for in this case. So I just went with this. So now what I'm going to do is, notice I use the second equation to solve this for y. So I'm going to go to the first equation, and I'm going to replace y. So this is, first equation is now going to look like negative 2x plus 7 times something equals 9. And I'm going to replace y with that negative 3/2 x minus 1/2. And then, this is 7 over 1. I'm going to distribute and just work this out. Negative 2x minus 7, that's 21 over 2x. 7 times negative 1, so negative 7/2 equals 9. If you don't want to work in halves, you can always, if you wish, just multiply everybody by 2. The least common denominator. So negative 2x times 2 is negative 4x. Negative 21/2 x times 2, the 2's cancel out, so you get negative 21x. Negative 7/2 times 2, again, the 2's cancel out, you get negative 7, equals 18 times 2, or sorry, 9 times 2, which is 18. And then I'll add 7. Combine like terms, negative 4x, negative 21x, so negative 25x equals 18 plus 7 is 25. Divide by negative 25, and you get x equals negative 1. And now that I know what x is, I can substitute that again. I can go back to one of the original ones, or I could go to this problem, whatever you wanted to do. So if I put negative 1 in here for x, that's going to, a negative times a negative is a positive 3/2 minus 1/2. Again, remember how you subtract fractions, common denominator. 3 minus 1 is 2 over that common denominator. So 1. So x was negative 1 and y was positive 1. And that's our solution point. So, and you don't have to just get integer numbers. You can get fractional values as well when you're doing this process. So that's solving system equations by substitution.